kidding. That's not what I do. All right, all right. Okay, so one more time. This is the Pixels, Particles, and Policy, a physics career panel put on by Women in Science Portland. We are a local nonprofit to Portland, supporting women in science and other marginalized genders as well. So thank you everyone for tuning in. I really hope you guys enjoy it. So let's get started. Let's meet our panelists. Let's start with some introductions. Rosemarie, would you like to introduce yourself?
Hi, I'm Rosemarie Higgins. I just give a little bit of background on where I'm at and why I'm here. So I majored in physics back in 2018 at Seattle University. I got my master's in applied physics in 2019, and now I'm doing physics for biology research at Pacific Northwest National Lab / Oregon Health Science University.
Sweet. What got you interested in physics in the first place?
I realized, about halfway through high school, I was really interested in just like all of the science, right? I knew that that's what I wanted to do. I was having tons of trouble picking a direction to go with that. And just kind of the more I thought about it, the more I kind of maybe naively convinced myself that all science eventually came back to physics, which obviously there's more to it than that. But I feel like I was right in a way in that coming out of school, I've realized like there are so many ways to apply physics to all of the fields of science. So I wasn't totally incorrect in deciding on it that way. And yeah, I also just thought lasers were really cool. That was a big part of it.
I love that's perfect reason. I love it so much. Sweet. Okay, so Hannah, would you like to introduce yourself?
Yeah. So hi everyone. I'm Hannah Judy. I was also a classmate of Rosemarie's. I was 2 years ahead of her. I graduated from Seattle University with my physics degree in 2016. And I got my master's in public policy, total career shift, which we can talk about later, in 2019. And now I live in Washington, D.C., and I sort of work in the mix of science policy, that kind of world. So I use my background in physics and science to inform people making policy decisions here in Washington, D.C., which has been very interesting. And so I guess how I got interested in physics in the first place is kind of a weird story, but my AP chemistry teacher in high school recommended me for this really random program that I've never heard of ever since. So I'm not sure what happened to it or where it came from, but he suggested I join this program that was sponsored by NASA and the University of Washington for like high school students to learn more about space, physics, aeronautical engineering, things like that. And we had like different homework assignments each week, and it was for a semester, I think. And we had like a practicum project at the end. So that was like my first introduction to physics, thanks to my chemistry teacher. And I actually started college thinking I was going to get a chemistry degree, but then I didn't like having goggles on my face all the time, and I had goggle marks all the time. And I was like, I can't do that. So I switched to physics, and I was, ever since it's been perfect. So
I love it.
Yeah.
I absolutely love it. They have those little fins now for like the side of glasses if you wear glasses every day.
Oh, okay. That did not exist. Or maybe I just wasn't told about this, but
no, I think they're new.
Okay, the damage is done. I can't go back now, so it's fine.
We would love to have you. I'm a chemist myself. We would love to have you back if you're ever interested. Oh, but awesome. Okay, let's move on to our last panelist. Kat, would you like to introduce yourself?
Sure. Hi, I'm Kat. I got my undergrad degree in physics from the University of Oregon, and I just received my master's in applied physics, also from the University of Oregon, through the same program Rosemarie just went through. So my background is high energy physics and optics. Rosemarie is totally correct. Everything really does come back to physics. I tell my kids that all the time when they ask me questions. And lasers are also really cool. I got into physics accidentally. So I went back to, I had a 10-year career as a massage therapist, went back to school, thought I was going into neuroscience. But when I moved to Oregon and decided I wanted to go to the U of O, there was no undergrad neuroscience program. So I kind of had to figure out how I was going to approach neuroscience. Was it going to be through biology or through physics? And the physicists I talked to were excited about the research, and the biologists weren't. So I said I wanted to be around people that were excited about what they're doing. So I started a degree in physics, working in a computational neuroscience lab. So my physics degree is super applicable in lots of scenarios. And then eventually decided I wanted to like actually do more hands-on physics research. And so now I'm finishing up my internship at Thermo Fisher Scientific, where I study electron microscopes. And I'm getting ready to start a new job working on fiber laser amplifiers next week.
That is so cool. That is so cool. Oh my gosh, we have such cool panelists. I love that you said you found it accidentally. I feel like, and perhaps this is, I mean, this is a very general statement, but women in general find the sciences professionally on accident, right? We're not super exposed as kids. We're not told like, oh, you can be a scientist or whatever. Like, it really is by accident that we fall in love with these things. And I'm so happy you pointed that out. Awesome. Okay, well, now that we are familiar with our panelists, why don't we move on to some questions, the meat of the video today. So we're going to get started with question number 1, and we're going to start with Rosemarie. How did you get started? Oh, no, we just answered this. Sorry, I just wanted to hear more. Okay, biggest challenge you faced in your career, and how were you able to overcome it?
Okay, yeah. So I think the specifics of this are going to be, I'll explain what happened, but I think that the whole idea of just not being listened to as much as you feel like you deserve as a woman in STEM is probably an experience that everyone watching this will relate to very strongly. So I was an intern for the first year of my career, doing sort of electron microscopy of semiconductors. I didn't love it. I'll talk later about my career transition, but basically I was hired as an intern in that position because I had experience with 2 different electron microscope instruments. I was familiar with transmission electron microscopy for imaging, as well as FibSem dual beams for basically making the tiny samples to image on the transmission microscope. My team was very familiar with using the former, not so much with the latter. So they thought I would be a great addition because I would have all this expertise in the other instrument. I didn't. And I just kind of knew how to use it. And they had this fantastic idea that I was going to make these crazy samples that no one had ever made before that were, totally brand new protocol, brand new everything. That instrument was very hard to get time on, so I spent tons of nights and weekends just sitting on this stupid dual beam trying to make these samples that no one had ever made in the world before. And it just wasn't happening. And I, for months, tried to explain to them, like, I can't keep spending my outside time doing this. It's just not working out unless you're going to give me, someone to help me or, any other resources, basically. It was just like, fighting against a brick wall. Nothing was happening. And eventually I figured out like the reason it wasn't working wasn't because I was bad at it. It was because the thing they wanted me to do was physically impossible. The resolution of that microscope is a lot lower than the other one. It was impossible to see the thing I was supposed to be targeting. And I tried explaining that so many times to my bosses and my mentors, never got anywhere. Finally brought in basically the guy in charge of that instrument to explain the exact same thing I'd been explaining to them. And of course he tells them once and they're like, oh, that makes sense. You don't have to do it anymore. And just, I'm glad that that worked, but I've carried that frustration with me for years of having, someone else, just some man with tenure in this role, tell them the exact same words I've been saying for months and have them listen to that when they wouldn't listen to me. And in future jobs, I feel like, that was my first job. I was an intern. I didn't necessarily feel comfortable advocating for myself in the way that I do now. And of course, the root of that problem isn't something that me advocating for myself more strongly is going to fix, but it has helped me to overcome facing similar situations in my current job.
Oh, yeah, absolutely. That makes so much sense. Like, if someone isn't like taking in what you're saying, there's no amount of advocacy or even just changing the words that you're saying that's going to get that through to them. Like, that is not a you problem, and that's huge to understand. It like in the workforce, we hear a lot about advocacy and speaking up for yourself, but sometimes there are positions or managers that just aren't ready to hear what we have to say, the way in which it's delivered, be that as a woman or an intern or whatever, what have you. That's such a good point. That's such a good point. Yeah. You talk a little, can you expand, and this is just me, my curiosity. So you say that you didn't have the confidence to advocate for yourself as much as you do now. How did you build that confidence? How did you how did you build the confidence to do that for yourself?
It's a really good question. I think just being in my career for a little bit longer, figuring out that, it's not that I don't know what I'm doing. It's that no one knows what they're doing. And most people around me talk about what they do a lot more confidently than I do. I guess that's imposter. It's like a subset of imposter syndrome that I kind of realized I was struggling against and worked to combat. And then, of course, I was only in an internship for 1 year, but in my current job, like, since I've had some longevity there, like, I have a proven track record of knowing what I'm doing. And just the more times that shows itself, the more I'm kind of reinforced that, I'm not the problem in most of these situations.
Yeah, definitely. Definitely. And I love that and I do have to point out, while you mentioned imposter syndrome, Rosemary is actually the president of Women in Science Portland. So, imposter syndrome can happen to everybody. It doesn't matter where you are in your career or what positions you've held. Imposter syndrome affects all of us 100%. And particularly us as women. I mean, okay, so I know that there are a lot of career panels out there that you can attend and listen to that are amazing and have great information. And I think, Rosemary, the way that you kicked us off with that answer is absolutely amazing to get to kind of the point that we want to stress during our panel events, is that we're coming at this from a point of view that is unique to women, right, in STEM, where historically we've been incredibly underrepresented or not represented at all. And figuring out, as we're coming in, what traditions have been in place, what biases have been in place that we now have to challenge. And hopefully our employers and coworkers are doing that alongside us, are also challenging those biases. But ultimately, because it affects us the most, we are the most aware of them. And so I love that you mentioned that first and foremost. Like, that is the information that you're going to get here. So Hannah, I'd like to throw it to you. What's been the biggest career challenge you faced so far, and how did you overcome it?
So similar vein as Rosemary, of not being heard or not being listened to. And I would say this was actually, this was the catalyst of why I changed career directions and left sort of, physics or hard science and moved to policy work. After college, or senior year of college, I, didn't know what I was doing next. And the typical thing that you do with a physics degree is you get a PhD, and that's kind of what all of our professors were pushing. And I didn't know really what I was doing. And so I said, okay, that's cool. I guess I'll get a PhD. And so I applied and got accepted into a program at the University of New Mexico. And I had already decided that I had wanted to sort of focus on the nuclear side of physics, so nuclear engineering, nuclear physics, things like that. And I had gone down to the University of New Mexico, and I visited the department there and met with a professor whose research I found interesting, and had sort of done all the legwork you do before, you start a program like this. And when I started in the fall of 2016, fall of 2016, it was like a 180. It was like a complete 180. So the program ended up not having any women in it. It was all men. I was the only woman, and there were no women professors either. And these were just things I also hadn't really considered. Like, nothing I had really thought about would be a problem when I thought about these programs. I didn't think that it was going to be such a obvious difficulty to get across, but it was lesson learned there. But so the professor that I had already met with and already visited before starting the program, who said, you know, let's work together and I'm going to let you work in my lab and here's what we're going to do. He then sort of shifted and said, well, now you need to get all of these certifications and all of these approvals before you start working in my lab. And months were going by. Like each week I was like, okay, I did this certification, you know, when can I start? And he was like, well, now you need to do this certification. And it went on for months, like through the whole first semester. And I complained to the department head and I was like, I don't understand what's happening. Like, I'm not sure why other people are already working in labs and I'm not working in a lab. And the department head was totally just not hearing what I was saying, sort of like what Rosemarie was going through, which I think is a pretty common occurrence. And his solution was, forget about working in the lab. Why don't you spearhead an initiative for us to get more women in the program instead? And you can be the advocate for our program to try and get more people to apply. And I was like, that's cool. Totally love that. But that's not why I'm here. And I'm not sure why that falls to me. And no, you know, I'm not going to do that before I start doing some research. And I'm not sure why you're not supporting me getting research done. And he was like, well, it's probably just not a good time. And I was like, that's fine. It's not a good time because I quit the program and I'm leaving. And I just stood up in that moment and I was like, I'm quitting. And, you know, that's of course when they were like, oh, no, like, don't worry, we'll get you in the lab. Like, we'll make sure you have lab time and like everything will be fine. And I was like, no, I don't think so. And so I just quit right then and there and called my parents and felt like a total failure, you know, even though I wasn't a failure, but it sort of comes back to this like imposter syndrome of me being like, why was I there in the first place? You know, these people didn't think that I was worthy of their time anyway, which obviously is not true at all. You just sort of get into that mindset. But it was actually the greatest thing that could have ever happened because I knew deep down that's not really the path I wanted to go down anyway. So it worked out for me. And while I had been living in Albuquerque during that time, I had also been interning at a nuclear weapons non-proliferation nonprofit. And they had told me, why don't you get your master's in public policy and move to Washington, D.C.? And I was like, that sounds great. And so that's what I ended up doing. And it just all worked out. You know, had I not gone down and tried this program and had that, you know, sort of negative feedback and negative interactions, then I wouldn't be where I am today. Not that I say it's worth it, but it was sort of like the hardest thing I've gone through in my career, but it worked out pretty well.
I'm so glad you turned that into a positive outcome. It was not a positive experience, but it was a positive outcome.
Right, exactly.
That is, and I love that. I really appreciate that you said the year that happened, 2016. That is so recent.
Yeah.
At least it's recent to me. That's still happening. I mean, physics especially is, I mean, I know I mentioned it earlier, but incredibly underrepresented, you know, women population. So while it makes me really sad to know that that's still something that happens in a male-dominated industry. But I am so very happy for you for, you know, communicating your boundaries during that time and then enforcing that boundary
Right.
when they kept violating it. And
I was shocked that I did that. I mean, that's a big thing to ask of anyone, especially in a, you know, position like that. So yeah, it's a huge thing. I'm not sure what happened. I don't know why I did it, but it just in the moment felt right.
The birth of your self-advocacy. I love
it. Exactly.
That's amazing. Oh my gosh. Yeah, no, that's such a hard topic to be in, especially like, I mean, as students, we're essentially trained to respect the opinions and directions of our teachers and professors and to follow that path because they know best. And then, you know, you had the confidence to question that and reach out, and it really, really sucks that no one listened to you, but you kept doing it. And then you essentially showed them the consequences of what doing that would be in the future. So hopefully they've taken that feedback, you know,
I hope so.
and done something positive with it.
Yeah, I hope so. Some self-reflecting.
Yeah. I mean, that's really all we can do, right? Is we can
Yeah.
give feedback and then move on because like you said, when they tried to put you in that advocacy role, you were like, that's not what I'm here for.
Right.
You can't put that position on me.
Right.
And I think that's such an important message to carry forward. Like, you only accept the responsibilities of the things that you are actually there to do. And that would be your job or
Yep.
your research, as it would be.
Yep.
Awesome. Okay, Kat, I'm going to throw it to you. Biggest challenge you faced so far in your career and how you were able to overcome it.
Okay, well, first of all, I want to reinforce something that Rosemary said, because imposter syndrome is something that we all face, and learning how to hold on to those little wins and kind of use those to build, that's huge, because I've experienced many of the same things that she has. I think we all have. And so just really learning how to be like, oh, somebody listened to me and they like what I'm doing. And so now I feel useful, like holding on to that, because there will come another time when like you don't get listened to and you feel like a complete idiot and failure and you wonder why you're there. And then you have to remember, wait, no, but in this other situation, I actually did know what I was doing. So I know what I'm doing. I deserve to be here. It's not always me. So yeah, really holding on to those little wins. Okay. So I think, the biggest challenge that I have faced in my career has been work-life balance and finding places that accept what my work-life balance is. So I have 4 kids and I have a husband who works out of state like half the year. So much of the time I am a single mom to 4 kids, which means I have a really hectic and sporadic schedule. Going all the way back to my very first year of undergrad physics, when I'd made it through first year of undergrad, I was getting ready to choose classes for the next year. And I was realizing that the course load that I had taken was not something that I could maintain. I was really struggling with my physics classes. I didn't have the time to devote to the physics and the math and all the other stuff, plus all of the things for my family. So I went to the only person that I knew at the time on campus, who was my professor, and I laid it on the table. I was like, this is what I'm going through in life. I want this degree. This is kind of what I'm thinking of. What do you suggest? Because I was thinking of doing school year round, doing all my, all my other credits over the summer, and then just focusing on the math and the physics during the academic year when I really had to, when only those classes were offered. And my professor told me that if I had kids and this was an issue, that I probably shouldn't be a physicist and that I should find an easier degree path. And so it's in the back of my mind pretty much every day. And then I would see him around campus. And after like 5 years and I was still in the physics program, I was like, nope, I'm still here. You didn't get me to leave. But what that experience taught me was that I need to advocate for myself. And I need to put up boundaries. So as far as looking for jobs, like for me, I went into my internship, and then now that I'm starting a new job, I spent like the last 6 months looking for work. Having patience to not apply to jobs or to turn down jobs that I know aren't going to work, even if they sound interesting and I want them, is challenging. But also just being communicative. So in the position that I have now, it started off as I was supposed to be in the office 8 hours a day, 5 days a week, very, very set schedule. And very quickly it turned into, well, I actually have to leave at like 2:00 every single day to go get my kid from school, and then all of this other stuff. And it was nerve-wracking to go to my new boss and say, this is what's going on at home. This is what I need to be successful. But I stood up for myself. I set boundaries, and I got what I needed. And I work from home like 70% of the time now, and I'm productive. and nobody cares because I'm productive. But I stood up for myself and I said, this is what I need. And so really being able to advocate, it's scary, doing that. And then Rosemaria touched on boundaries too, like putting up boundaries. Like there's times when I fight for tool time, but I've also made boundaries and say, I'm not coming in on weekends and I'm not coming in after this time because this is the time I need with my kids. I will find other work that I can do from home. If it's an issue and you want me to be working during these hours, I will find work I can do from home. I'm not going to go, I'm going to be home with my kids when I need to be home with my kids. And so really just standing up for myself in those situations. But you come across a lot of people who don't want to listen when you say those things. So as a woman, a woman with a career is expected to have a full career, but also be mom. I'm expected to do all the stuff for the kids. I'm expected to do dinner and all of those things. Whereas many of my colleagues, they have wives at home that go pick up the kids, that then make dinner, that do all of these other things. I'm still expected to do both. And I've definitely interviewed with people that you can tell right off the bat, they don't care. They want you there. They don't care what your life and family responsibilities are. And so it's been a challenge to find people who are sympathetic and understand that, especially as a woman raising kids, my needs for work are different than many. I think probably every woman with kids would say the same thing, but we are so few in this industry that advocating for that is a thing. So yeah, that's, I think, been my biggest challenge.
Yeah. Oh my gosh. I love that you brought up parenting in, A, any workforce, but B, in a science. And you said you had to struggle for total time. I love that, how you put that. But you mentioned, is your workplace male dominated?
Oh, very, very much so. I see maybe 2 other women in the hallways, and I have a friend who works upstairs. I just don't ever see her.
Funny. Yeah, you mentioned that, while you have to, go pick up your kids at a certain time, you're essentially functioning as a single mom for half of the year. Even the other half of the year when your partner is around, you still have responsibilities.
Yeah.
And the way you worded, your colleagues have wives and, partners at home to take care of those responsibilities, brings up a really important and often overlooked bias within the workforce, which is the women are expected to, have the caregiving responsibilities and not, the men. And that is, it's not limited to just the STEM industries, but it is something that, those are the biases that we're talking about. Like, they affect us the most, we see them the most. And there's a really interesting, and I'm going to plug the Courage campaign here, since we are getting very close to the topics that they cover. And so I'm going to drop that link in the chat box below. That is the Courage campaign that's happening right now through Women in Science Portland. And, you mentioned you received a little bit of pushback initially, right? When you said you had to dip out at 2:00 to go pick up your kids. And, what was that feedback that you were given? Did they, at any point, were they like, you're so dedicated to your family? Like, what kind of things did they say to you?
I went to my boss and I said, this is what my family situation is. And this is when I'm going to have to leave. And these are the 2 things. I was like, I can either do this after I pick up my son, or I can do this, but you're going to have to let me do one of these 2 things. And I was pleasantly surprised with the reaction, because what I got was, well, you're supposed to be on site this many hours. I would not normally allow this, but I understand your need to get your kid. So why don't you, do this plan that you had come up with, and we'll see how this works for a little while, So I was really, after, the first story that I told about the professor and how that went, I was really pleasantly surprised with how little pushback I actually got from my current manager. So, I mean, in that respect, I have a good team that I work with. And then it really comes down to, finding those people that are caring.
Right. Yeah, definitely. I love that. And that, I feel like, kind of shows the progress we've made, maybe not just as women, but as people, right? Fathers have kids. They have kids too. And so, it kind of shows, maybe, hopefully, I'm crossing my fingers that this is actually the conclusion that I need to be drawing from this, is we've made progress, right? People understand that families are responsibilities, and responsibilities that everyone who has kids have, not just women.
So I will say on this topic that there is one of my colleagues that's on my team has a young daughter, and he will frequently leave to go pick her up and such. So it is nice to see that duality of male and female parenting responsibilities and how that's coming across at my office. I think at least, and I see a lot of that, I think at least where I'm working right now, I think in general, there is good understanding. But I've certainly, like I said, I've interviewed with companies where I'm like, oh God, no.
Yeah, I totally understand that. Absolutely. And I know that this isn't physics specific, but it's so important to talk about. Like it impacts so many things, up to and including the retention of women in STEM as they progress in their careers. Right? Because you don't have kids when you're right out of college generally. I know that's not always the case, but as you get older, the more likely you are to have children, and the more it impacts women specifically. There have been studies shown that men who have children are rewarded in the workplace with a little bit more significant pay bumps, and women are negatively impacted by having children, and they generally make even less than their female counterparts who don't have children, who make less than their male counterparts, period. So, that is one thing that definitely impacts, a couple's decision, if it's a male and female relationship, who, if someone has to stay home with the kids, who that's going to be, is really impacted by those biases. My hope is that, Kat, with your with your anecdote, I hope that is the way that the industry is moving. I kind of hope that that's the way the world is moving. We just got to keep, again, advocating for ourselves and putting down boundaries. Like, these are the things I can do, and I'm dedicated to my work, but I'm also dedicated to my family, and having that balance is really important. And not, Rosemary, not staying late or on the weekends, when you would rather be spending time on your own recharging, be that with your family, or on your own. We don't have to work 80-hour weeks anymore. And I mean, and I could go, this is one of my soapboxes, I could go on for hours, but I think it's a good time to move on to our next question. Can you see me? Can you hear me?
I can hear you. But
okay, there we go.
There you go.
My screen went black for a minute. Okay, so let's move on to our next question. We've talked about this a little bit, but what has your experience been with career transitions and changing interests? Rosemary, I will toss it to you first, if you'd like to answer.
Yeah, so I alluded to this very briefly earlier, but my interests have evolved quite a bit over time, especially since my decision to do physics was mostly based on an enthusiasm about science in general. I should have predicted that eventually I'd want to kind of cross fields. And as Hannah said earlier, like, our professors at Seattle U were very much like, yeah, maybe there are a couple paths, but for the most part, y'all just need to, like, get a PhD in pure physics, which is a very daunting path to even think about. And even if you do that, it's very rare that you're going to end up in a career where you're just doing physics, right? I think in, chemistry, biology, it's pretty easy to have more of a linear path, where no matter what kind of degree you get, you could just have a job in that field. With physics, physics is unique in that that's not almost ever the case. And I kind of wish that in school we had been more encouraged to try different kinds of sciences. I took one biology class and I was like, this is really cool, but like, I had one biology and one chemistry and then all of the physics, and that was kind of my only exposure to like how I might kind of cross-contaminate fields. And I just continued on this linear path. I did the internship, which was still very, it was more engineering-y, but it was still pretty straightforward physics. I knew that's not really what I wanted to do. It was fine, but it just wasn't like, besides some like work culture issues, the work wasn't making me wake up every day and be like, yeah, I'm so excited to look at semiconductors and do physics about them. And like, I went to a conference halfway through my internship. It's just like a microscopy conference at large. And I was so shocked. I don't really know what I expected going in, but probably 2/3 of the content there was related to microscopy applications to life sciences. I remember being just all grumpy the first day because I was like, I should have done more biology classes. Like, I wish that I could go into something like this because I have a physics degree and I can't. But then I took a step back and I talked to like everyone I could there, and I realized like, actually, like with the skill set I have, this is super applicable. I have so I was working on a microscope like this. It's big one. Here's me. So, this is what I was using for the semiconductors. And then this is the one that you use on the life science side. They're almost exactly the same. They have some different optimizations. But I learned at that conference that like, since I knew how to use this, I barely had to learn anything else to be able to like use the same skill set in life science. And I was really, really lucky to talk to someone at that conference who had hired a physicist in the past and was interested in hiring more, because it kind of got like, we have enough people who understand the biology, but this is like such an interdisciplinary thing to use electron microscopy in biology, that, it takes all kinds, and we want people with this background as well. So that was exciting because for the first time, so, that was in 2019 and I started physics in 2014. So hadn't thought for those whole 5 years about like which field I would use my physics in. That's just not something we ever talked about. But it was pretty easy to make that jump once I realized that it existed. And now I'm super happy because I still very much get to use a lot of the physics I learned in school. I'm drawing upon like 90% of the courses I took to some extent. But all of my impacts are in biology, which I've since developed a huge interest in. And yeah, I feel like just without having ever thought about what that might look like, it felt like such a huge transition. But if there had been any discussion when I was in either my undergrad or my master's about like, you're not just going to do physics, that's extremely unlikely. What else are you interested? What do you want to do? That wouldn't have felt like such a huge leap. But yeah, it worked out really, really well.
I love it. I love that. Because that's something I didn't know as a non-physics person, that you couldn't do just straight physics, right? As a chemistry, technically biology turned chemistry major, I was always under the assumption that I would be doing the straight science of whatever I chose. So that's really interesting. That is really cool, though. So I almost asked our next question, but we've got 2 more panelists to ask this question too. Hannah, would you like to talk a little bit?
Really quickly, just in case you don't have time. I will say that the way I was able to make that leap, I'm pretty sure, was me showing just so much unfettered enthusiasm about the biology application that they didn't care that I didn't actually know anything about it. They're like, she's so excited that she'll learn whatever we tell her she has to learn, and that worked out very well. So that's what I'd recommend.
I love it. Find something that you're enthusiastic about is great advice. Awesome. All right, Hannah, how about you? Career transition.
Yeah. I guess before I talk like specifically about my personal career transition, I'll just keep talking about what Rosemary was saying. I think actually we're kind of lucky when we get physics degrees, because we can do like, there are so many job applications that come from having a physics degree that aren't even scientific related, like, or STEM related in general. You know, like with a physics degree, you can go into, you could be a statistician, you can be an economist, you could work on Wall Street. Like you can basically apply, and I've just learned this in my own lifetime also. I think it's a myth that you would have to have, unless it's for something very specific like chemistry or biology. In general, I don't think having a specific degree matters. I think it's about using, like, playing up the skills you've learned. I think we're lucky being physicists that we have gotten, or people in STEM in general, get some really great skills out of their degrees, like critical thinking, problem solving, working really well under like a lot of pressure. And like those are skills that are good for any type of job. And so, yeah, I do wish we had known when we were in undergrad that the world was kind of our oyster, even though that might be a little too overwhelming to know at that point. But like we really could have applied to a lot of things, or focused on a lot of other things that we didn't realize were available to us. So I'll just make that plug that, you know, don't think that you're limited to just physics or, you know, just STEM if that's not what you're thinking of. Because I know when I finished my degree, my parents were pushing me. They were like, just get a job at Boeing, be an engineer. Like, what are you doing? Like, why, what else is there? Like, what else do you need to do? And I was like, I don't want to do that. I never pictured myself working in the lab. I love physics, I love math, I love science, but I just like did not see that for myself. And I had just no idea, if I wasn't gonna be in a lab, I was like, what else am I supposed to do? Like I truly had no idea. My professors didn't have any guidance, and you know, my parents don't know, and because they're not scientists. And so I just kind of was like left flailing. And but so for me personally, in our program, our senior year, we do an ethics and physics class. At least I think so. Did you take that, Rosemary? Yeah. Where they talk about mainly like the Manhattan Project and the development of nuclear weapons, and, you know, like what it means to be a scientist, like an ethical scientist, and how to like not compromise your morals. And I found that class to be really interesting. And so I kind of already knew that I wanted to sort of like focus on the non-proliferation nuclear weapons side of things. If I wasn't going to end up doing science, I was like, well, that sounds pretty interesting. And so, yeah, like, I think that's what Rosemary was saying. It's about like finding what you're interested in and being passionate and like enthusiastic about it. And so even though I was starting this PhD program in New Mexico, I was like, well, I'm still gonna do this internship at this nonprofit because that sounds way more interesting than whatever I'm learning in class right now. And so I did that. And like those connections that you make are how you sort of get to that next step. You know, like, I don't know how to say it any other way, but like you can't plan too much almost. Like if you want your career to go in a direction, like my advice would be to not really plan too hard, like every year, or like every, you know, within 5 years, I want to be this, doing this. It's more of like trying to make the right connections and guiding yourself to like where you want to be. And I know that sounds kind of like wooey and not really like a great advice, but that's just how it has worked out for me personally, is like I have sort of had a vision for myself, and that has just sort of worked out each step of the way. So
yeah, amazing.
Yeah,
amazing. I mean,
it really answers the question. I sort of went off on like a tangent, but that's just how I feel. Like I hope people know that like just because you have a degree in something doesn't mean you're beholden to like that topic, and that there really is a lot of opportunity for us. And that you just have to like know how to play up your skills, because we have some great skill sets.
Oh, absolutely. Absolutely. I mean, it really just sounds like we need to plan on following our inner values, right? Yeah. Like you said, like, you know, maybe don't plan the career path too hard, but definitely plan on adhering to what your interests are. Right. And being okay with changing up whatever, right. Whatever you're doing for that. That is great advice. That is great second advice, especially as scientists who aren't encouraged to listen to our gut super hard.
Exactly. Like that's what I would say too, is, you know, at least for me, it was really difficult to sort of let go and just be like, okay, I'm not sure how this is all gonna work out, but I'm gonna try this and see, because this seems better than what I was doing before. Like any step is a step forward. Like whether it's good or bad, like you are making a decision to like expand yourself and your knowledge, and you grow from that, whether or not it's a good experience or a bad experience. Hopefully it's not a bad experience, but like growth is growth. And so like, don't let yourself think that like, just because you're in one position now doesn't mean that in the future, like you have to still be there, or that you can't make a change that you want to make. Like we are not stuck in time or in stone. Like we can do whatever we want to do. So there you go.
I love it. That was fabulous. That's perfect.
I'll get off my soapbox now. I'm done.
I feel like because we're part of this organization and doing this panel in particular, we all share the same soapbox. We're all standing on it like friggin' Olympic medalists. Let's throw it to Kat. Your experience with career transitions and changing interests.
So I'm definitely a big supporter of changing interests. Long ago, I read this article that said that the happiest adults are those that have made major career changes at least once in their lives, because it keeps things interesting. And so I was a massage therapist for 10 years. And as I got to the end of my career, which came because my hands were starting to hurt, I decided that I actually wanted to go and pursue a degree in science like I'd always wanted. And so it's totally doable. I mean, so I had like a major career change. It's been a whole lot of fun. There's definitely times when I look at my colleagues and I'm like, well, damn, if I'd done this 10 years ago, I would totally be them right now, right? Instead of like just at the same age as them, but just starting off. But it's been a lot of fun, and I've really enjoyed making such a large transition. And like I said, just advocating for myself and for the needs that I have with where I am in life has been huge. And then really just to second what Hannah and Rosemary have said, I think as physicists, at least for me, the biggest thing that I've gained from my physics degree is how to problem solve. Like, yes, I know physics. Yes, I know particles. I know optics, but I know how to problem solve. I can look at a problem where I have no idea of where to begin and be like, maybe I'll try this. And then I'm going to fail. And then I'm going to gain some insight about what to try next. And that is a skill that is applicable everywhere. So I mentioned briefly before that I started off in computational neuroscience. I was applying my problem solving skills there. I was looking at data sets and looking for patterns in data sets, those same skills. And I learned some coding doing that. Those same skills I transferred over to particle physics, which is all learn how to code, extract this information, make a pretty graph, and then look at it and make sense of it. And those, I learned the particle physics stuff along the way. Like you learn the terminology, you learn the specific equations, those things you learn along the way. But it's the problem solving that is so applicable everywhere. I mean, my physics degree, I could go and be a business analyst because of the skills that I have with math. So really, you can do anything with it. And you shouldn't expect to do physics with it. I've got these slides from the American Physical Society that talk about career trajectories. And there's this one fantastic slide, and it's like physics master's students. And like, once you get your master's, where they're working, and then PhD recipients and where they're working. And by the 10-year mark, everybody's working in the same place, except for like 3% of PhDs who are still actually in academia. But by the 10-year mark, whether you have a master's or a PhD in physics, you're not in academia, you're doing something else, and you're applying your physics degree in some other way. So yeah, like Hannah said, the world's your oyster. It really is.
That's awesome. That is so cool. I had no idea how flexible career paths could be with a physics degree. That is so cool. But I do believe we are about at time. If there are any questions, we will end our recording here. Thank you so much to our career panelists for taking the time today to talk with us. We will have all of the recorded information sent out. It'll be posted on the Women in Science YouTube channel, as well as emailed out with the summary of the event. Yeah, all right.